or my challenge statement is basically that engineering curricula relies heavily on cookbook experiments and structured labs. So this definitely presents an opportunity where students need to be able to design experiments and develop their critical inquiry skills. The other challenge is that students might be comfortable with wearable technology to assess health and wellness, but especially first-year students, they might not be familiar with the underlying sensors that are used to acquire physiological signals. And I do have to admit that this was heavily inspired by the work of Isabel Miller and Holly Golecki on their development and implementation of a biometrics device design project in an introductory BME course. So this was also implemented in a first-year biomedical engineering lab. One of the resources that we already had was that the VCU BME department's quantitative physiology course uses the AD Instruments Power Lab data acquisition device, as well as their human physiology collection of modules. So my question was, we wait until sophomore year to give them these experiences, and they're very tailored, they're very structured labs experiments. But what if we give students just enough guidance and then let them design their experiments on their own? And then also ask them how might we incorporate these findings into a wearable device or an app in order to improve users' health and fitness. So below is just an example of one of the pathways that students have used. So this one was an experiment related to reaction times. And as students just took data on themselves, I'd listen in on their conversations and hear things like, oh, I think my reaction time's really slow because I stayed up late last night studying for an exam, right? Or some students would say, oh, my reaction time's really good because I got plenty of sleep. So I would have them kind of make these observations and ask them to see if they could craft a research question around it, and then design an experiment where they could just take their data. So this is an example of students just taking data on their own, where they would find days within their schedule where they might notice that they have less sleep or more sleep, and then just compare what their reaction times might be. And then I had them propose a device or app that might simplify the setup so that then they could give it to a user and that user could incorporate it into a daily health and fitness practice. So as an example, they could create an app where the user would have to react to a particular stimulus and they would record that. So after implementing this module, some of the reflections that I received were that students were really excited to collect physiological data very quickly and easily. And the great thing was that they had an opportunity to evaluate their experimental procedures and treat the experimental procedures as a prototype itself. We learned from that panel earlier that even just prototyping small experiments and being able to quickly get feedback on whether or not we feel like this is the right track was really, really important. And that was definitely something that my students felt as well. And then for future work, some of the plans that I have for this module would be incorporating smaller sensors so that we can closely approximate what students might need in order to develop wearable devices. And then also adding an assignment to teach students to use wireframes or things like Canva or PowerPoint animations in order to communicate app ideas. And then finally, we do always have issues with the small sample size. The students are only taking data on themselves, so they only have an N of 3 or 4. So I've considered things like publicly available data sets, but my issue with that is that I don't want to be too prescriptive. I like having the flexibility of letting the students take the data and then see where that goes.